In this video, we will consider the formulas for sine, cosine, and tangent of a sum and of a difference. Let's jump right in and present the formulas. Then we will consider specific problems in which the formulas are used. First, we have that sine of a plus b equals sine of a times cosine of b plus cosine of a times sine of b. I like to think of this formula in terms of what it means. The sine of a sum is the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. Next, we have the formula for a sine of a difference. This time, sine of a minus b equals sine of a times cosine of b minus cosine of a times sine of b. The sine of a difference is the sine of the first times the cosine of the second minus cosine of the first times sine of the second. Notice in both of these formulas the sign, S-I-G-N, matches, and the terms are mixed in terms of sine and cosine. The cosine of a sum is given by the formula cosine of a plus b equals cosine of a times cosine of b minus sine of a times sine of b. And the cosine of a difference is cosine of a minus b is cosine of a times cosine b plus sine a times sine b. Notice that in the cosine formulas, the terms match and the SIGNs are opposite. Now let's consider two applications of these formulas before moving on to the tangent formulas. Let's find the exact value of cosine of 5 pi over 4 minus pi over 6. Note that if we combine the fractions and parentheses, we get 13 pi over 12, and we do not know the value of cosine of 13 pi twelfths. Thus, we will use the formula for cosine of a difference shown here. We substitute the values of a equals 5 pi over 4 and b equals pi over 6 into the formula. Now we have special value angles whose cosine and sine values are known. Recall that both cosine of 5 pi fourths and sine of 5 pi fourths are negative root 2 over 2, since 5 pi over 4 is in quadrant 3. Also, we know that cosine of pi over 6 is root 3 over 2, and sine of pi over 6 is a half. Now there's only arithmetic and simplification to perform. So we multiply fractions, and then combine the fractions with the common denominator to get the quantity negative root 6 minus root 2 all over 4. In our second example, let's find the exact value of cosine of pi over 12. Note that this is not a special value angle, but perhaps we can rewrite pi over 12 cleverly in terms of special value angles. Note that pi over 12 is equal to 4 pi over 12 minus 3 pi over 12, which equals pi over 3 minus pi over 4, which is the difference of a special value angles. We can now use the formula for cosine of a difference shown here. So cosine of pi over 12 equals cosine of the quantity pi thirds minus pi fourths. We substitute the values of a equal pi over 3 and b equal pi over 4 into the formula. Now we have special value angles whose cosine and sine values are known. Both cosine of pi over 4 and sine of pi over 4 are root 2 over 2, and we also know that cosine of pi thirds is 1/2, and sine of pi thirds is root 3 over 2. Now there's only arithmetic and simplification to perform. So we multiply the fractions and combine the fractions with a common denominator to get root 2 plus root 6 all over root 4. Now let's consider the addition and subtraction formulas for tangent. The tangent of a sum is the sum of the tangents divided by 1 minus the product of the two tangents. Similarly, the tangent of a difference is the difference of the tangents divided by 1 plus the product of the tangents. Let's work through the proof for the first of these identities. Starting with tangent of a plus b, we use the definition of tangent as the ratio of sine to cosine. Then we can use the addition formulas for sine and cosine. Notice we want to end up with an expression involving tangents. So we divide the top and bottom of our fraction by the product cosine A times cosine B. In other words, we multiply by a clever form of the number 1. When we distribute in both the numerator and denominator, we notice that some simplification can occur. So we reduce each individual fraction by canceling 1 where appropriate. Then we again use the definition of tangent as the ratio of sine to cosine to arrive at our desired expression. Now let's use the addition formula for tangent to find the exact simplified value of tangent of 7 pi over 12. Again, we notice that this is not a special value angle, but we can rewrite 7 pi over 12 in terms of special value angles. In particular, we notice that 7 pi over 12 equals 4 pi over 12 plus 3 pi over 12, which is actually pi over 3 plus pi over 4. So now we can use the addition formula for tangent that we just derived. So tangent of 7 pi over 12 equals tangent of pi over 3 plus pi over 4. We can substitute the values of a equals pi over 3 and b equals pi over 4 into the formula for tangent of a sum. Now we have special value angles whose tangents are known. We know that tangent of pi over 3 is root 3, and tangent of pi over 4 is 1. So we get the quantity root 3 plus 1 over 1 minus root 3. This expression is not simplified due to the radical in the denominator. We multiply by a clever 1 of the form 1 plus root 3 over 1 plus root 3. We've chosen the conjugate of the denominator to utilize what we know about the difference of squares. Then we multiply the fractions, remembering to FOIL the binomials in the numerator and denominator. Notice that root 3 squared is 3, and combine like terms. Finally, we factor a minus 2 from the numerator and cancel with the denominator to get an exact simplified answer of negative 2 minus root 3. On some of these problems, the algebra required to simplify presents the biggest challenge. There's no substitute for algebraic proficiency here. For our final example, let's consider a problem that requires some clever substitution. Find and simplify the sine of the sum of inverse cosine of a half and inverse sine of 3/5. To begin our solution, let's first recognize that what we really want to find is the sine of a sum. The summands are just ugly. Let's simplify the summands by calling them alpha and beta. In particular, let alpha equal the inverse cosine of a half, and let beta equal the inverse cosine of 3/5. Beta equal the inverse sine of 3/5. Then cosine of alpha is a half with alpha between 0 and pi, and sine of beta is 3/5 with beta between negative pi over 2 and pi over 2. We know that to find the sine of a sum, we need the sine and cosine of both angles. We can find the sine of alpha using the Pythagorean identity and knowing that alpha is in quadrant 1 or 2 where cosine is positive, and also substituting cosine of alpha equal 1/2. Similarly, we can find cosine of beta. We know that cosine of beta is positive because beta lies in either quadrants 1 or quadrant 4. Finally, we're ready to find the desired quantity by essentially finding sine of alpha plus beta. We utilize the addition formula for sine and substitute in the known quantities. Finally, all we do is simplify. In these problems where you need to make appropriate substitutions, a good bit of practice is required. In general, if a quantity is an angle, I like to name it with a lowercase Greek letter. For example, since inverse cosine of 1/2 is an angle, I named it alpha, and inverse sine of 3/5 is an angle, which I named beta. This trick or technique takes a little bit of practice, and you need to remember the definitions of the inverse trig functions.